Now I'm going to talk about some charts, some tools for analysis of process variability. While I talk about these concepts with respect to quality, we can implement them for flow time, to evaluate inventory, and for throughput. So they can be implemented to analyze all capabilities of a manufacturing or a service process. We can use them to check the quality of the product with respect to safety, durability, ease of use. We can check them regarding price of the product, regarding the delivery time, and regarding service. All of these needs to be based on data. We cannot have subjective analysis. Here are some useful tables and graphs. The first one is check sheet. Here we list the problems and then we check each problem or each complaint. For example, regarding cost, how many times have we realized that there is a problem with our cost, with our response time, with our after-sales service quality? And because these graphs were prepared for a garage door, how many complaints or observations we had regarding the quality of the product. This is just a table which will list the problems and record their frequencies. Then I have Pareto chart, which differs from check sheet in two aspects. First, this is a visual representation. This is a graph, schematic representation. This is a tabular representation. Tabular representation, which is good, and graphical or schematic representation. Please note that besides writing and speaking representations, we do have tabular representation where we can translate several pages of narratives into a table, and we have schematic representation in which we can translate several tables into a graph or translate a table into a graph with better representation. And finally, at the highest level of representation, we have mathematical representation. For example, we state throughput times flow time equal to inventory. This is a mathematical representation. Narrative representation, tabular representation, schematic representation, and mathematical representation or analytical representation. All of these are modes of communication. Then here we have a histogram, a set of intervals. State that how many observations we have had in each interval. For example, when I am deciding about your final grades, I create a histogram either based on the overall grade or based on A, B, C, D, plus and minus, and F. And usually I have minimal F in my classes. And then I prepare something like this, which is a histogram. This specific case is related to the weight of a garage door, and it considers points where the weight was too high, the product was heavy, and it was not easy to use it. Check sheet, Pareto chart, histogram. I think we are fine with these tools. I think we have seen all of them before. Oh, I think I forgot about this Pareto chart to explain something. The difference between Pareto chart and check sheet is, first, this one is tabular, but this one is graphical or schematic. The second one is, in Pareto chart, we sort the item in non-increasing order of observations. I did not use the term in decreasing order of observation because we may have two problems where the number of observations are equal. Instead of using decreasing, I said non-increasing, which is applied as decreasing or staying at the same level. So in Pareto chart, we identify our problems and then draw them based on their frequencies. This will stay the first, second, third, fourth, and fifth. So the graph looks like this. Indeed, Pareto chart also has a general characteristics. It is not observed in all Pareto charts, but generally people say 20% of the problems appear 80% of time, and perhaps 70% of the problems appear 10% of time, and then 10% of problems appear 10% of time. That means if an institute has 1,000 problems, we do not need to partition our effort in 1,000 pieces and allocate one piece to each. Our responsibility is to identify the most important problems and address them first, and then go to the second layer of the problems, and then third layer. I think I have talked enough about this page, but if you have any question, bring it to our live sessions. Then I have a run chart, which shows the average of observation over time. For example, suppose every week we have a quiz, and then I have quiz 1, quiz 2, quiz 3, and then I draw the average of each quiz. The difference between run chart and multi-vari chart, beside the averages, we also represent the maximum and minimums. This is maximum, minimum over time. So usually we represent, say, the average of something, or a percentage of something, or the number of observations of something over time. Here we present averages. Here we present averages plus max plus mean. Usually when it goes for student grades in exams or in quizzes, instead of maximum and minimum, I usually get the second maximum and the second minimum. I think I have explained enough about these two graphs too. If you do have question, please bring it to our live session. This one is a neat tool. They call it cause effect analysis or fishbone diagram. For example, in this situation, we had a garage door. We were considering its quality, and we were trying to link it to material, to equipment that we have, to personnel, and to operational procedures. We are looking at the problems of our garage door. We want to know what problem is here, here, over there, and here. These four can be sources of problems. Regarding personnel, for example, we may find it out they are not well trained. We don't have enough incentive for them to motivate them to achieve a high level of quality. Regarding the material, we may find it out that we have not defined the specification very clearly, or we may find that there is a problem with a component, and that is due to a problem with the vendor. Here, regarding procedures, we may find it out that the problem with our procedure, which has been finally reflected in the low quality of our product, is we have not documented and standardized our procedures. So people are not practicing them the same. Regarding our equipment, so equipment is a source of the problem. Why it is source of the problem? Because we do not have good maintenance. Why? Because we do not have schedule to do these maintenances. This is a very useful diagram, cause-effect analysis or fishbone diagram. Find something which is not good or something which is good, and then we try to find its causes. So regarding the quality of the door, which one of its component was its weight, why are these doors so heavy? Because the metal sheet was too thick. Why the metal sheet was too thick? Because the roller at the steel mill were set incorrectly. Why the rollers were set incorrectly? Because supplier is not able to meet our specifications. Why did we select this supplier who is not able to meet our specifications and produce a metal sheet which is not too thick? Because our project supervisor was too busy and did not look for a well-qualified supplier. Why we put ourselves into this situation? Because our project supervisor is paid by meeting the production codes. By this tool, we go back to find sources of problems and sources of these sources and sources of these sources. So a key source is here, source of this problem. It is because of this, and this one is because of this one. This is the notation that we use to show what are the effects and what are the cause of that effects. Cause-effect analysis or fishbone diagram. This is another example of fishbone diagram or cause-effect analysis. Lead time of delivering our product is greater than 7 days and we are unhappy with it. Sources could be people, material, machinery, or methods. People, our employees, do not stay in our company for a long time. They come and leave. We have insufficient number of skilled workers. We do not have good training and motivation. Machinery, change over time from one product to another is high. We have frequent energy breakdown. We have lack of maintenance. Methods, material, we can go through all causes and causes of those causes. Here I have tried to provide you with 2 additional examples, and each team could think about improving this graph and the next graph, and then if you provide me with a good report, if you provide me with good understanding of these 2 graphs, I can give you 10 extra points to one of your quizzes. As you know, in our institution, average time to degree is greater than 6 years. So why it is like that? I think it is because academic presence, mental presence, and emotional presence of our students are low. By academic presence, I mean the time that they allocate to their education. By mental presence, I mean the level of focus when they participate in a class or when they are watching my lectures. Emotional presence, whether the student is intrinsically, internally motivated to learn. Then we have unit load. This is also maybe a source of a problem because suppose you are available 25 hours, qualify you for, say, if we assume that you need 7.5 hours for each 3-unit course, this will qualify you for less than 12 units because it is believed that for 3 units you need 9 hours or 950 minutes. Therefore, for 25 divided by 9 is something like 9 units. 3 units. So if you are taking 15 units or 18 units, you need to increase this 25 hours. We may say we have poor advisement. Math foundation of our student is not good. We may say our student do not have good reading and writing habits. We may say the students do not know the system, do not know how the system works. We may say courses are not well linked to the career. You may think of all of these, and then you may provide me a one-page report and a single graph, and I will acknowledge your contribution in things that are useful for yourself. Here is a similar graph, but here is a positive one. In the spring 2020, the grades increased significantly. We need to know why. Did the students study harder? Was it because the exams mostly were open book? Was it because the job market is tough and now the students are trying to learn better to be more compatible in job market? Did faculty taught better? Were there easier exams? Did we have easier grading? Did the system change? I don't like this one, but this could have been also a reason. So why grades in spring 2020 went up? And if there are positive points that we can emphasize on them and make it better, then it is good that we know the cause of those effects. This graph and the previous graph, if you give me something better than what I have given you, either in writing or in schematic form, starting from what I have and improve it, then you will get a couple of 10 extra points per student. I think I am done with this part, and then I will have a third part on this quality issue, which I will talk about process control charts. Thank you for attending.